So this video will hopefully be super quick because Mr. Burgoon kind of already taught you guys this a little while ago. Remember, I wanted you to do something the long way, and I was out one day and he showed you the shortcut. So I'm going to actually prove to you the shortcut. So what we're going to do is the sum and product of the roots of a quadratic. Okay, and remember, to find the roots of a quadratic, if it's really nice, you can just factor, right? Factoring is when it's really simple. That's what we kind of start you off with. But then we learn the quadratic formula. The quadratic formula finds the roots every single time for a quadratic. It could be something that you could have factored. It could be something that doesn't factor. It could be nice. It could be messy. But the quadratic formula always works to find the roots of a quadratic. And remember, the quadratic formula, which is not given to you on your reference table for the Regents exam, is x equals negative b plus or minus, so it gives us two possible roots, the square root of b squared minus 4ac, and that all of that is over 2a. Okay, so this gives us two possible roots. There's the plus version and the minus version. Oops, that is a horrible arrow. Two possible roots. Okay, and so what we're going to do is we're going to use the quadratic formula to actually find the sum and the product of the roots. And like I said, I'm actually going to prove it. Now let me minimize this so I can move to the next page. Okay, so let's go ahead and prove it. First, let's do the proof for the sum. So the sum of the roots. So the sum, remember, sum means add. Okay, so if I look, my first root is going to be x equals negative b plus the square root of b squared minus 4ac all over 2a. So that's my first root. And then the second root is going to be x equals negative b minus the square root of b squared minus 4ac, all of that over 2a. So I'm going to add these two roots together. So I'll come down here. So I've got negative b plus the square root of b squared minus 4ac. And I'm adding, because it's sum, the other root. Now what's nice is that even though these are kind of messed up fractions, these fractions already have common denominators. So we can go ahead and smush these all as one big fraction, because remember, to add or subtract fractions you need a common denominator, but they already do. So this is just going to be negative b plus the square root of b squared minus 4ac minus b minus b squared minus 4ac all over 2a. So I just smushed those numerators together, put it all over 2a because that's the common denominator. And now this is actually really nice because if you look, there's a lot of stuff in the numerator that I can combine. Okay, let me see if I can get my highlighter. Is it going to come up? Looks like not. Okay, so, but if I look at this, I can take this b right here, this minus b, that is a horrible circle, and I can combine it with this other minus b over here. So I've got minus b, that's going to give me minus 2b. Okay, and then if you look, I've got that positive b squared minus 4ac and that minus b squared 4ac. Those two things are actually going to cancel. So this is going to cancel with this. Okay, so those things cancel. The b's combine to give me a negative 2b, and this is all still over 2a. Well, those 2's are going to cancel, and I'm just going to be left with negative b over a. So in general, when we are doing the sum of the roots of a quadratic, to find the sum, that's going to be negative b over a. Now, if we're actually doing a legitimate example, oops, there we go, new page, go to a new page. Okay, so we just proved that the sum is equal to negative b over a. So if I give you the quadratic, that's like 3x squared minus 6x plus 2. This is a y equals. And I ask you to find the sum of the roots rather than go through and try and factor to find the roots or do the quadratic formula to find the roots. I just know that the sum is negative b. Well, here's my b. So it's going to be negative 6 all over a. My a is 3. So that's going to give me positive 6 over 3, which is 2. So the sum of the roots for this quadratic is just 2. Okay, so that's how you could find the sum without actually having to go through and actually find the roots. We can do a similar proof for the product of the roots. Okay, so product proof. Okay, so now I'm going to multiply my two roots together. So I'm going to have negative b plus the square root of b squared minus 4ac all over 2a times negative b minus the square root of b squared minus 4ac all over 2a. Okay, now remember with fractions you do not need common denominators to multiply, you just go straight across the top, straight across the bottom. Well, multiplying the bottoms are easy. 2a times 2a is 4a squared. But the top is a little more complicated because you have to FOIL. Okay, when you FOIL, you get negative b times negative b, that's b squared. Okay. Here, negative b times negative b squared minus 4ac. Now, really, that's just, don't get too complicated. That's just the negative and the negative cancel, so it becomes a positive, and then you've got b times b squared minus 4ac. You can't simplify that anymore. Please don't try. Then when you do the inners, they have different sides, so it's going to be a minus, but you still just have b times the square root of b squared minus 4ac, not my c. And then when you go ahead and you do your left, you have a square root times a square root. Those square roots cancel. Okay, now you got to be careful though, because this is a minus because they have opposite signs, and then all of this is in parentheses, b squared minus 4ac. So let's clean this up a little bit. For starters, these cancel, which is nice. And then I need to take this negative sign and I need to distribute it. Please, please, please remember to put those parentheses and distribute that negative sign. When you do, you get b squared minus b squared plus 4ac all over 4a squared. Now these cancel, and I'm left with 4ac over 4a squared. And look at that, the 4's cancel, and the a in the numerator cancels with one of the a's in the denominator, so you're just left with c over a. So the product of the roots of a quadratic is c over a. So if I go to the last example that I was doing, if I wanted to find the sum, I'm sorry, I already did the sum. If I wanted to find the product of the roots, I just derived the formula that it's c over a. So I look, well, c is 2 and a is 3. So the product of the roots would be 2/3. Okay, and actually, if we go through and actually find the roots of this quadratic, let's see, 0 equals 3x squared minus 6x plus 2, we can see if this factors. And I don't think it does. But foolproof way, let's do the quadratic formula. So we will get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which simplifies to 6 plus or minus the square root of 36 minus 24 all over 6. 36 minus 24 is going to give me 12. Okay, so, and I can simplify the square root of 12 because that's going to give me 6 plus or minus 2 radical 3 over 6. Okay, and let's see what happens when I actually add those two roots up. Let me extend my page. I don't know why my page keeps doing that. But when I try and add these, all right, and I did my sum up here in orange, so I'll do the sum down here. I've got 6 plus 2 square root of 3 over 6 plus 6 minus 2 times the square root of 3 over 6. These cancel. 6 plus 6 is 12 over 6, which is 2. So this was a heck of a lot more work, but I did get the same answer. Okay, and if you check it by multiplying out these two roots, you will get 2/3. Okay, so it does save a lot of time. So the biggie is knowing these two formulas right here. I'm not going to ask you to prove them, but you do need to know them. And that is it for your